And welcome back to another video on my YouTube channel. So in this one I'm going to be talking about the EVM. You've probably heard about this. We'll learn. It's very important because if you're a smart contract developer, EVM is part of this smart contract ecosystem, because EVM basically it's the engine on the blockchain that compiles. It's not like an engine, but it's a virtual machine that compiles your smart contracts that you write in Solidity into bytecode, and that's why we will quickly go over this stuff so you have a general idea of what's happening. So let's learn about what EVM compatible means. You will hear this term often refer to blockchains. So the Binance Smart Chain, for example, is EVM compatible, and this means the smart contracts you will write and the smart contracts you can deploy and write to Ethereum, you can also deploy to Binance Smart Chain. It because this Binance Smart Chain is basically a fork of the Ethereum chain, and the EVM there can compile these contracts into bytecode. Let's actually give you a definition. Basically, the Ethereum virtual machine, this is by the way the blockchain, the network, and here you have EVM into the blockchain. And if you don't know what this picture is, want to know in details what the blockchain is, watch the previous video in my smart contract for beginners playlist and you'll get it. And EVM basically means stands for Ethereum virtual machine, and it means it's basically a runtime environment for smart contracts on Ethereum. So what type? So let's just go ahead and see what type of accounts do exist on the Ethereum blockchain. So basically there are two types of accounts. The first one being the smart contract you're already writing here. So you can even say, as a smart contract developer, you can say, oh, I'm developing wallets instead of smart contracts. But I don't know if you would like to do that. And also you have externally owned accounts like MetaMask. And yes, smart contracts, if you didn't know, they're referred to oftentimes as the apps on the blockchain, which makes sense, but really they are wallets and they aren't controlled externally like these accounts are. These are basically, you can call them user wallets, and these are controlled by code. But these are both wallets because they both have an address. These smart contracts we are developing here into Remix are basically living or residing at a specific address, like you would have like your normal public address that you have on your MetaMask, and they both can store balance. You probably use MetaMask all the time. You have balance on your MetaMask, and the smart contracts you're developing can also hold funds, crypto basically. And let's see now how is data stored into smart contracts, into these wallets as we call them. So every smart contract, basically it's a program, so a program must have its own memory because you want to store some data in the program. And these smart contracts have its own persistent storage, sort of like the SSD on your MacBook Pro. Hopefully you're using a MacBook Pro because it's the best computer out there. And basically the storage they have is they have a lot of storage. Let's just start off with that. And their storage is saved in this array. So everything on the smart contract is saved in this big array, and it has a lot of slots in it. It has 2 to the power of 256 minus 1 slots, so you can store a lot of data. And I didn't mention, but in each slot you can store 32 bytes of data, and that's a lot of storage. But you hear this term often. Often people say that, oh, it's very expensive to store data on the blockchain, which is very true. And this guy even did the math. I don't know if it's right, but I just found this on the stack exchange, and basically to use up all the data on a single smart contract, I think that's what this guy is saying, you would need $250 trillion. So, whoops. Okay, let's now see what are transactions. So I don't know if the contents of these videos are formatted, the structure is the right way, because said I was going to talk about the Ethereum virtual machine and then I'm just talking about transactions. But let's first of all, transactions are whenever you want to basically change the state. Let's actually go here so we can use our little map. So on this computer, so it's based. This is the blockchain, and it has some data stored. And whenever you want to change this data, you need to make a transaction. And basically, all a transaction is just if we now, let's say, were to deploy this contract. So as I was saying, if we were to deploy this smart contract, we can interact with it as such. As you can see, I've defined this deposit function and withdraw function. And if I click on these buttons, they're red because they're payable. If I click on these buttons, basically I'm interacting with the smart contracts, and that's what you're doing each time, and basically that's making a transaction first of all. And you can only, another thing that's important to understand is you can only initiate a transactions from an externally owned account. So there are two types of accounts, as we said previously. The first one being the smart contract, and the second one being this externally owned account. And you cannot initiate any transaction from a smart contract, because this is just code. It's a wallet, but you cannot. But you can do, what you can do is initiate a transaction from your MetaMask to this to interact with this smart contract, and this smart contract can interact with this smart contract. And you will learn about transactions and how this works in this course. But for now, that's it. Another important thing you need to know, of course, is gas. What is gas? Gas is something you pay. You can think of it when you're driving a car, and sending a transaction would be analogous to driving a car in this example. And if you want to drive the car, you have to pay gas. And if you want to make transaction on the blockchain, again, you have to pay gas. And this gas, that's basically it. So we'll go more into depth when later, when we're going to make some transactions and code up some stuff. But for now, that's it. Okay, another useful thing I may add, actually that's not it. When you make a transaction, as we said previously, you can interact with you will interact with this smart contract, and this smart contract will interact with this smart contract, let's say. So you have to provide the gas needed to execute this code, but also this code. But don't worry about this, you'll learn more about this in depth into later videos.